Hey all, so welcome to today's lesson. This is kind of a review where we've done solving quadratics by factoring and by graphing, but we're going to reinforce that and do some more problems to really make sure that we're solid on it, because this is a fairly big part of the Regents and just the algebra course in general, knowing how to solve quadratics. All right, so in your warm-up, and again, just a reminder, if you haven't done the worksheet at all, just give this a pause, go do it, and then come back. Okay, so I'm going to look at both of the parabolas, right? So both of these guys, that one and that one. And I would like to know which equations represent those quadratics. Now, I could put each of these equations into my graphing calculator, right? And then I could just see which ones match. I could also solve them using that zero product property. And let me try and do that. So again, if I change this y to 0, then I could set each factor equal to 0. So I would have x plus 3 equals 0 and x minus 2 equals 0. All right, now I'm just going to solve these. Minus 3, x equals negative 3. Oops. And here I'm going to add 2 to both sides of that equal, and I get x equals a positive 2. All right, so in this particular equation, let's call it equation 1, all right, I have roots that are a negative 3 and a positive 2. All right, so let me see. Here, negative 3 would be here. And a positive 2, oh, okay, so positive 2 is one of them, so that one does work. But I need both of them to work. All right, let me try this one. So here I've got negative 1, negative 2, negative 3. This would be the root. Let me just erase those dots. Okay, and then the other one would be x equals 2. Okay, so again, this one doesn't hit either of those roots, right, on the graph. Okay, so I'm going to erase my work, and I know that it is not this first one. Okay, now again, if I change this to 0, and I've got x minus 3 equals 0, and x plus 2 equals 0. Let me erase these. All right, let me figure out what my roots are. So for the first one, if I add 3 to both sides, I should get x equals 3. And the second one, if I subtract 2 on both sides, I should get x equals negative 2. Now, if you haven't noticed, whatever the sign is inside the parentheses, the root is the opposite sign. So if you haven't noticed that, start kind of looking for it. All right. Okay, so here I've got the roots of x is positive 3. So here positive 3 is right here. And negative 2. Okay. So it doesn't match this one because this dot over here, that's not part of the root of the parabola. Okay. So let me see the other one. So again, I'm at positive 3 and negative 2. Yes, that works. I have both of my roots right here, and they match with negative 2 and a positive 3. Excellent. And if you notice, those numbers are in the parentheses, but they're the opposite sign. So if I've got roots of a positive 3 and a negative 2, in parentheses, I should have a negative 3 and a positive 2. So the same numbers, but I'm switching their sign. All right, so I'm going to erase that one and see what else I got. Except I know that these are a match, which is pretty cool. So let me use the blue, and I'm going to say, hey, this matches with that. All right. So now this one, see how I have a -3? That means one root will be x equals +3. And see how this is a -2? My other root will be x equals a +2, right? Those are the roots. Okay, so here I have a +2 right here and a +3 right here. So these match. All right, so when the directions say, hey, match those guys up, I know that the middle equation, this one right here, matches with this quadratic. And I know that the last equation right here matches with the first quadratic or parabola. All right, let's move it on. Okay, so this is super cool. They want you to factor this to solve for x, and they also want you to graph to find where the parabola hits x. All right, let me just write x here, right? This is my x-axis. So where it hits the x-axis. All right, now, one thing that I hope you're able to peep is that this is a difference of two squares, right? So I've got x squared, which is, again, x squared is x times x, which is y. It's a perfect square. And 1 is a perfect square because it's got 1 times 1. So these are two perfect square terms, and there's a difference. There's a subtraction in the middle. So I set up my parentheses, and I've got x and x. And now the 1 is 1 and 1. And if you remember from our lessons, the only thing that's different about this is the sign. So 1 has a plus and 1 has a minus. All right. Feel free to get your area method, make that box, right? And you will see that those are the only factors that would go on the outside of the box to give you these factors of x plus 1 and x minus 1. All right, so cool. So again, zero product property says that if I've got a 0 here, right, this is the ZPP, right, zero product property, it doesn't work for anything but 0. That tells me that I can set each factor, right, so this is one factor, x plus 1 equal to 0. All right, so I can set each of them. So my other equation would be x minus 1 equals 0. All right, so now I'm just going to subtract 1 here. I'm just going to solve these. X equals -1. And here, let me solve that quickly. Here I've got x equals a +1. So again, these are my roots, my solutions, my x-intercepts, right? Remember all those words. So at -1 and at +1. Okay? I know that those points are where my quadratic is going to intersect with the x-axis. All right. So now let me do this by graphing. So I have 0 equals x squared minus 1. And remember, we call it the zeros because we actually make the y value equal to 0, right? So if I say y equals 0, you would get exactly the same line as the x-axis. All right, let me put those points back in there. All right, those are supposed to be right on the x-axis at +1 and -1. clean that up a little. All right. It is harder drawing with your finger than you would think. All right. So how do I put this in the calculator? You simply replace that 0 back with y. Y equals x squared minus 1. Okay? So if you don't have a graphing calculator, I would suggest that you get your graphing calculator. Remember, there are a bunch of apps that you can go to. Put this in your graphing calculator, and I want you to get me that table. Now I'm just going to erase this as I always do, give myself a little bit more room. So I've got x and negative. Oops, why did I put that? X and y. Okay, so I know that I have when x is negative 1 and when x is 1, both of these guys, the y value is 0. Okay, so when x is 0, that's negative 1. And remember, when x is 0, that is my y-intercept. So that will go right here. Let me make that green so you can see it a little bit better. Okay. And now let's just do maybe 2 other points. So let's see where negative 2 brings us. And positive 2. Okay. So negative 2 squared is 4 minus 1 is 3. And 2 squared is also 4 minus 1 is 3. All right, so 2, 3. 1, 2, 3. And negative 2, 3. Okay. You could do more points, but that's all I'm going to do right now. All right, I'm not going to go all the way to the edge, so I'm just going to put a little arrow. Okay. Now, if you notice on your table, you have exactly the same roots as you got over here. All right, those should always be the same. So no matter what method you use, you should always get the same answer, the same solution, root, x-intercept, all of that. All right, so we have practice problem number 7. And this is kind of cool. 1, notice again that they changed the y to a 0. That is to set us up for the 0 product property. All right. So I have my 0 over here. And now, if you notice, all of these have a common factor of 2. They don't have common x's, right? They don't each have an x term, but they do have a 2. So not only am I going to take out 2, I'm going to take out negative 2. All right. So I have negative 2. And again, I really love using the distributive property to figure out what's left in there. So negative 2 times x squared gives me 2x squared. Negative 2 times a negative x. Remember, a negative times a negative gives me a positive 2x. All right, so now negative 2 times a negative 12 gives me positive 24. All right, so all I did there was I took out the GCF. So I factored it using greatest common factor. Now, if you see inside, I've got x squared minus x minus 12. And that one's not as easy, at least for me to see, than the last example, which was difference of perfect squares. That one is pretty easy for me. But maybe it's the reverse for you. Maybe that one was tough and this one's super easy, or, any kind of combination. So I'm just going to do my box method real quick. And I might have to erase this because, I'm always running out of room on these. So take a pause, take a picture if you need to still see it. All right. So let me make this. All right. So this here is in standard form, meaning it goes inside of the box. So my first term, which is x squared, goes in my first box. And my last term goes in my last box. Now, it's kind of nice having x squared, because the only factors that could give you x squared would be x times x. I guess that's not really true. You could have x squared times 1, but I've never really seen it where it's not just x times x. All right, and so now I know that these two boxes, whatever they are, need to add or subtract to give me a negative x. And for those of you that forget, it's really a negative 1x. All right, so now I need to know, what are my factors of 12? Well, if it's a negative 12, I do know I need a positive and a negative. Okay. And actually, let me do these in a different color. X times x, and I know I need a positive and a negative. Why a positive and a negative? Because that is the only combination that will multiply to give you a negative. All right. So a positive times a negative, or a negative times a positive, but they've got to be different signs. All right. So let's play around with 12. So 12, I have 1 times 12, 2 times 6, and 3 times 4. All right. So if I want to get to a negative 1x, 3 and 4 are the only pair that have a difference of 1. All right. And since I want them to combine to a negative 1, I'm going to make the bigger number the negative. All right. And look at what that does. So 3 times x gives me positive 3x. And negative 4 times x gives me negative 4x. All right. When I combine these, negative 4x plus 3x gives me negative 1x. So I would have x squared, I would have negative 12, and 3x minus 4x, I would have negative 1x. Okay, so those are equivalent, but one is factored form. All right, so here's where I'm going to erase it. I told you I would. I can write those back in. Okay. So what do we have? We had x squared minus x minus 12, right? Okay. Let's get rid of all this. Alrighty. So remember back, hopefully you have it in your notes. I have 0 equals negative 2. That negative 2 didn't go anywhere. And then parentheses, x plus 3 was one of our factors on the outside. And x minus 4 was the other. So here we did factored form. All right. So now what? Oh, zero product property, right? ZPP. And that states that when you have all of your factors being multiplied to give you 0, you can set each factor equal to 0. So if it's in a parentheses, that's considered one unit, one factor. So my first factor here is negative 2. I can set that equal to 0. X plus 3 is my second. I can set that equal to 0. And x minus 4, I can set that equal to 0. All right, so is that true? Is negative 2 equal to 0? All right, so because this is not true, that's false, right? There's no variable. It's just saying negative 2 is 0. No, it's not. That is not a real factor. All right, so that's not going to show up on our graph. All right, so here I've got negative 3 on both sides. 3 minus 3 is 0. So I got x equals negative 3. And here I have 4, 4. And I have x equals a positive 4. All right, so let me move things around. I lost my calculator. All right, you guys are going to have to help me in spirit. So I have a negative 3, 1, 2, 3, and a positive 4, 1, 2, 3, 4. All right. Okay. And remember, this is the x-axis, but it's also the equation y equals 0. So we really just changed this 0, or this y, into a 0 to give me the x-axis to see where they intersect for your solution. Right? And sometimes, well, we'll get to that later. I was going to say sometimes you can use your calculator and actually put y equals 0 and then use it to find the intersection points. But another lesson. I get too excited about math. All right, so here we go. We have y equals negative 2x squared plus 2x plus 24. Let me rewrite that because y. And all I've done here is I've just changed that 0 back into a y. Okay, so put that in your calculator. I'm just going to set up my table. I might need to erase what's down here. What else is new? Okay. And I know that at negative 3 and a positive 4, my y values were 0. Okay. All right. So now let's see what's negative 2. Actually, let's not do all the points. Let's do 0, especially since I misplaced my calculator. So if I have 0 squared is 0 times negative 2. So all of this turns into 0. I'm left with 24. Oh, I didn't even see that at the beginning. This is a negative. So my y-intercept will be way even further, but that's the highest point I can go. So it would be way up there. Okay. Interesting. All right. So I'm just going to draw a sketch. I would like you to draw it better than me. And I will do better about having my calculator on hand next time. All right. So yeah, so this right here would be a positive 24. Remember, standard form, you can always tell what the y-intercept is. Okay. All right. So regions-based question here, because they are all in parentheses, those are different factors. So the first thing I need to do here is look at my graph. It intercepts where y equals 0, which again is exactly the x-axis. And I see it crosses, it intersects that x-axis at 1, 2, 3 points. And so let me see. This looks like negative 1, negative 2. This looks like a negative 3. Here, this looks like 2. And maybe this looks like, I think that's, 4. Okay. So my roots would be x equals negative 3, x equals 2, and x equals 4. So I've got 3 intersections, 3 roots, and if you remember, the roots are the opposite sign of what's inside the parentheses. So I would be looking for x plus 3, x minus 2, and x minus 4. Always the opposite sign. All right. So I see x plus 3, x minus 2. Oh, well, that's pretty easy. So it would be this one. You could immediately knock out 3 and 4 because I've got 1, 2, 3, 4 roots, and I only intersect this graph 1, 2, 3 times. All right, so the answer choice would be number 1. All right, questions, comments, and concerns, you guys know what to do. I will see you at the next lesson.